All right, so as we were saying, when we're solving our logarithms, the first thing we want to do is switch them to their exponential form. All right, so they give me log base 7 of 7. I don't know what that's equal to. I'm going to put an x there and then switch it to its exponential form. So that would be 7 to the x is equal to 7. So now I want to get my bases the same so I can set my exponents equal to each other. Since the 7s are already the same, I know that this is 7 to the first power, and so I can just set my exponents equal x is equal to 1. We also have a property that says that if you're taking the log of something and you have the same base, that your answer will automatically be 1. All right, then for this next one, we have the log base 5 of 1, so I don't know what that's equal to. I'm going to set it equal to my unknown x, and then switch it to exponential form. 5 to the x equals 1. Now, there's no way to get my bases the same here and set my exponents equal like we were doing. This one just requires that I know a law of math that anything to the 0 power, other than 0, is going to equal 1. And so for that reason, we have a property that says if you're taking the log of 1, regardless of what's your base, that answer is always going to be 0 because this base will never be 0. So that will give us x is equal to 0. All right, look at the next one. So the next one, again, I don't know what this is equal to. I'm going to set it equal to x and then switch it to an exponential. So that'll be 3 to the x is equal to 1 over 81. So I need to get my bases the same. That means I need to find a way to write 1 over 81 with a base of 3. So let's focus on the 81 first. So in my little calculator, I can say 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81 is 3 to the 4th. Now I need to get this 3 to the 4th out of the denominator, and the way that we do that is with a negative exponent. So remember, a negative exponent makes it move across the division bar. So now I have 3 to the negative 4 over 1. So now my bases are the same, and I can set my exponents equal to each other, so I'll get x equals negative 4. All right, for f, we are, again, I don't know what that's equal to, so I'm going to set it equal to an unknown x and switch it to its exponential form. 2 to the x equals 1 over 32. Now I've got to find a way to get 1 over 32 in terms of 2. I need a base of 2. So let's start with the 32. So I could say 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that would be 2 to the 5th. And again, I need it out of the denominator, so I need to move it across the division bar with a negative exponent. Now my bases are the same. I can set my exponents equal to each other, so x equals negative 5. All right, for g, I've got the log of 100. So again, I don't know what that's equal to. I'm going to set that equal to x. Remember that when there's no base on a logarithm, that is the common log. That's the log base 10. So if you want to insert a 10 right there, you can. All right, so again, I'm going to switch this to its exponential form. So 10 to the x equals 1,000. So I need to get my bases the same. I need to find a way to write 1,000 with a base of 10. So 10 times 10 is 100, times 10 is 1,000. And so now my bases are the same. I can set my exponents equal, and x is equal to 3. All right, then for this next one, I've got ln e. Now, we have a property that tells us ln e is equal to 1. And if you remember that, fantastic. But if not, we know that ln is the natural log. Its definition is that ln is just like an abbreviation for log base e. So you can replace ln anytime with log base e since they're the same thing. All right, I don't know what that's equal to, so I'm going to give it an unknown x. And so now I can switch it to exponential form. E to the x equals e. All right, now this is e to the first power. I only have one e right there. So now my bases are the same, and I can set my exponents equal to each other, and x is equal to 1. All right, the next one, we've got ln 1. So I'll set that equal to my unknown x. And so ln is the same thing as log base e. So replace ln with log base e and switch it to its exponential form. So that would be e to the x is equal to 1. So you remember we talked about a moment ago right up here that when you have the log of 1, that's always going to be 0 because anything to the 0 is 1 other than 0. So same thing here, I have the log of 1 that's going to be 0 because when I have e to the x is equal to 0, anything to the 0 is equal to 1 other than 0. So that is also one of our properties, or you can work it out like we just did. All right, so for this next guy, first off, I need to get rid of this fraction. So I want to get this e to the 4th up to my numerator. So I'm going to use the negative exponent to do that. So now I have ln e to the negative 4. Now, ln is the same thing as log base e. And remember that we said that logs and exponentials are inverses of each other. They cancel each other out. So ln e cancels out, and whatever my answer is, or whatever my exponent was up here, that would be my answer. So if this was ln e squared, the answer would be 2. If this was ln e to the 7th, the answer would be 7. If this was ln e to the negative 5, the answer would be negative 5. All right, we also could do that same property in reverse. If you raise an exponential to a logarithmic with the same base, because they're inverses, they cancel out. So this is the exponential base e, and ln is the log base e. They're inverses, they cancel out. So then my answer would just be 7, all right? We also can do that with values other than e. You know, like this was e to the log base e. I can do that 5 to the log base 5. Those cancel out and give me 3. If it was 7 to the log base 7 of something, then they would cancel out and just give me whatever this number is right here. All right, then for number 19, what does x equal if log base a of 4 equals log base 8 of x? So we have a property that says, because they've told us this is equal, and the log with base 8 is the same on both sides, then that means that what we were taking the log of must be the same on both sides as well. So x would just be 4. All right, and then last, what's the domain of a log? So we have seen on our calculator that if we put in the log of 0, we get an error message. If we put in the log of a negative number, we get an error message. You cannot take the log of 0 or a negative number. You can only take the log of positive numbers. So whatever I'm taking the log of, I'm just going to set that greater than 0 because you can only take the log of positive numbers. So then I could add 5 to both sides, and I also could write that in interval notation. Doesn't matter what else they have out here on the equation. It's just whatever you're taking the log of has got to be greater than 0.